All right, welcome back. Now we've got another example. Now in this example here, they give us 3 points. So one of the things that we can use the distance formula for is to verify triangles, right? Especially right triangles. So if you remember, the Pythagorean theorem says if the square of the lengths of two of the legs, right, add to the square of the hypotenuse, then you have a right triangle. Because what does Pythagorean theorem say? A right triangle, if you have a right triangle, then the relationship between the lengths of the sides is going to be what? The sum of the square of the lengths will equal the square of the hypotenuse, right? So, in other words, if you have a right triangle, right, then a squared plus b squared equals c squared, right? But also, it goes the other way around. If a squared plus b squared equals c squared, then you have a right triangle. Okay? So that's what we're going to use. We're going to use the Pythagorean theorem, the definition of, to help us decide whether we have a right triangle or not. So in this example, they're giving us the points that represent the vertices, right? The locations of the vertices of a triangle. And so we're going to find the distances between all three, and we're going to use those distances to see whether we have a right triangle or not. Okay, so let's do MP, right? So let's do distance MP. And so that distance is going to be what? So let's do -2 minus 4 squared plus -3 minus 1 quantity squared. So we'll do that one. Okay? And then we've got PQ, right? Distance PQ. And so that distance is going to be what? PQ is going to be, let's do 4 minus -1 squared plus 1 minus 7 quantity squared. And then finally, QM. And so that distance, we can write that as what? QM is going to be -1 minus -2 squared plus 7 minus a -3 quantity squared. Okay, so now let's solve for each of these. So this gives us a -6 squared, which is 36, plus -4 squared, which is 16, which is going to give us the square root of 52. Okay, now I'm going to leave this like this, okay? Just leave it with the square root, and you'll see why in a moment. Now, this distance is going to be what? This is 4 minus a -1, so that's 4 plus 1, so that's 5. So that's going to give us the square root of 25 plus, and this is -6. 1 minus 7 is -6, which is going to give us 36, which is going to give us the square root of what? 61. And then finally, we have this distance for this point, QM, and this is going to be -1 minus a -2, which is going to be the same as -1 plus 2, which is +1. So +1 squared is just 1. And then this is going to be 7 minus a -3, which is the same as 7 plus 3, which is 10. So that's going to give us 100. which is going to give us the square root of 101. Now, of all three of these distances, the largest one is the square root of 101. So that one is the only one that can be the hypotenuse. Okay? So now if we take all three of these distances, so this is leg 1, leg 2, and the hypotenuse, and put it into the quadratic formula. So we're going to do the square root of 52 squared plus the square root of 61 squared equals the square root of 101 quantity squared. Now, that's why I didn't want to simplify this any farther, because the square roots will be undone by the square, so this will just give us 52 plus 61 is equal to 101. Now, is that a true statement? No, because this side adds up to 113, and that is not equal to 101. So this tells us that we do not have a right triangle. All right. So there you go. Have a good day.